Welcome to Tungala 9 classes. In the last class, we completed the numerical number 46. Now, today we are going to start from the 48. A block of mass m is placed on the rough inclined plane of inclination theta and coefficient of friction is equal to mu k. A force of mg into sin theta plus mu k into mg cos theta is applied in the block in the upward direction. The acceleration of the block is. So, problem number 48. So, inclined plane will be considered. Over the inclined plane, an object of mass m will be placed. Angle of inclination is equal to what? Theta. Now, so if you resolve the component of the weight, mg sin theta component is always acting down the plane. Mg sin theta component of the weight is always acting down the plane. So, over that block, in the upward direction, how much force is applied? In the upward direction, applied force value is equal to mg sin theta plus mu k mg cos theta. Mu k mg cos theta. So, this is a pulling force applied in the upward direction. Then, what value they are asking? The acceleration of the system is. See here, this surface is the rough inclined plane. So, whenever you would try to pull the object in the upward direction, frictional force is acting in the downward direction. Frictional force value is equal to here. Frictional force F is equal to mu mg cos theta. If you observe the diagram clearly, the downward force value is equal to F downward is equal to here F upward. Downward force is equal to what here? Mg sin theta plus frictional force value is equal to what? Mu mg cos theta. This is the downward force, and whatever the force they was mentioned in the given numerical, that upward pulling force is equal to mg sin theta plus mu k mg cos theta. If you observe these two terms, downward pulling force is equal to upward pulling force. Downward pulling force is equal to what? Upward pulling force. So, whenever a equal amount of the force is acting on the body in the opposite direction, so that the net force acting on the object is equal to 0. Net force acting on the object is equal to what? 0. If the net force acting on the object is equal to 0, acceleration of the object is equal to 0. Hence, the correct option is what? Option number 4. So, that is a given numerical 48. Next, 49. A block of mass m and a surface area capital A begins to slide down an inclined plane when the angle of inclination is equal to pi by 5. So, it is also rough inclined plane concept. An object will be placed over the rough inclined plane, Angle of inclination value is equal to theta is equal to pi by 5. Theta value is equal to what? Pi by 5, and mass of the given object is equal to what? Small m, and they mentioned the area of contact. Area of contact value is equal to capital A. Area of contact is equal to what? Capital A. Next, keeping the mass of the block will be same. If the surface area is doubled, the angle of inclination of the plane at which the block will be sliding is. So, angle of inclination at which the block will be sliding means the angle of inclination is nothing but angle of repose. Or the angle of repose or angle of friction will be equal to what? Mu is equal to tan theta. Already we have the relation between the coefficient of the friction and theta. Theta is what? Either angle of repose or angle of the friction. So, here mu value is equal to tan theta. Here mu value will be depends upon what value? Angle of repose or angle of friction. Already we told the sliding friction as well as the kinetic friction. Both are independent of area of contact. So that whether you change the area or not, the mu value does not be changes. As a result, the angle of repose is also does not changes. So that the correct option is what? Pi by 5. So what is the answer? It is independent of area of contact. Independent of area of contact. Next. Problem number 51. 51. See here. The angle of inclination of an inclined plane is equal to 60 degrees. Angle of inclination is equal to what they given? 60 degrees. Suppose we are assuming that the body will be placed on the inclined plane. The body will be placed on the inclined plane. So what values they given? Angle of inclination theta is equal to 60 degrees. And the coefficient of friction mu is equal to 0.2 they given. Coefficient of friction is equal to what? 0.2. Mass of the block m is equal to what? 10 kg. G value is equal to 10 meter per second square. So this is the given data in the numerical number 51. So in the numerical number 51, what they mentioned, angle of inclination is given, coefficient of friction given, acceleration due to gravity given, and the mass of the given body is also given. Now, the acceleration of the body down the plane is Already we derived the formula, it is a direct bit. So whenever the object will be sliding down, down the inclined plane, so acceleration formula A is equal to G into sin theta minus mu k cos theta. G into sin theta minus mu k cos theta. All the values are given. G value is equal to 10. Theta value is equal to what? 60. Sin 60 is equal to root 3 by 2. Sin 60 is equal to what? Root 3 by 2. Mu value is equal to 0.2 and cos 60 is equal to 1 by 2. Cos 60 is equal to what? 1 by 2. If you simplify, you will get acceleration value is equal to what? A is equal to 7.66 meter per second square. 7.66 meter per second square. Direct formula. While the body will be sliding down the inclined plane, acceleration value A is equal to G into sin theta minus mu k cos theta. Next, 52, 53, 54 all are related to the 52. See here. In the above problem, for this given data, the resultant force acting on the body is In this case, the body will be sliding downwards. With the effective acceleration of A is equal to G into sin theta minus mu k cos theta. So that for the numerical number 52, net force acting on the block is equal to, already we know, according to the Newton's second law, F net is equal to mass into acceleration. F net is equal to what? Mass into acceleration. What is the mass of the block? Mass of the block is equal to 10. Mass of the block is equal to what? 10, and acceleration value is equal to what? 7.66. Therefore, the net force acting on the block is equal to what? 76.6 Newton. 76.6 Newton. So, whenever you know the acceleration of a given block, according to the Newton's second law, net force acting on the block is equal to mass into acceleration. So, that is about problem number 52. Next, problem number 53. Next. Again, for the problem number 51 data in the above problem, the frictional force acting on the body is, so whenever the block will be sliding downwards, frictional force is acting up the plane. So frictional force general formula F is equal to mu k into N. F is equal to what? Mu k into N. So frictional force F is equal to, what is the mu k value? Mu k value is equal to 0.2. N is equal to what? When the inclined plane you consider, already we told normal reaction value is equal to what? Mg cos theta. So N into Mg into N value is equal to what? Mg cos theta. Substitute the values. 0.2, M is equal to 10, G is also equal to 10, and cos 60 means 1 by 2. Cos 60 is equal to what? 1 by 2. 0.2 into 10, 2. and 2 will be getting cancelled. Frictional force F is equal to what? Frictional force F is equal to what? 10 Newton. Which type of friction will be existing here? Kinetic friction. Why kinetic friction? The body will be in the motion. Like that we have to solve the numerical number 53. 53. Next. Problem number 54. In the above problem again, the minimum force is required to pull the body up the inclined plane. Up the inclined plane. See here. Problem number 54. So what they are saying that what is the minimum force is required? What is the minimum force is required to pull the block in the upward direction? So whenever the motion of the body will be, in the up the plane, so frictional force will be acting down the plane. Frictional force will be acting down the plane. Always mg sin theta will be acting in the downward direction. So that whenever the body will be sliding up the plane, mg sin theta always acting in the downward direction, frictional force will be acting in the downward direction. So they are asking the minimum force. Whenever they will be asking the minimum force, this force value is equal to, pulling force is equal to sum of the downward forces. That is mg sin theta plus Fk. mg sin theta plus Fk. So all the values are there. So what is the mass value? 10. G value 10 and sin 60, that is equal to what? Root 3 by 2. Frictional force value just now only you calculate, that value is equal to 10. If you simplify, you will get 96.6 Newton. 96.6 Newton. So like this we have to solve the problem number 51, 52, 53, 54. Next problem, important one. A brick of mass 2 kg, just begins to slide down, on the inclined plane at an angle of 45 degrees with the horizontal. The force of the friction will be, So whenever the object will be placed on the inclined plane, already we told mg sin theta force will be acting in the downward direction. Since it is a rough surface, frictional force will be acting in the upward direction. So what is the meaning of the limiting friction? The limiting frictional force is the minimum external force is required to slide the body or to bring the object into the motion. So here also, whenever the object will be placed on the inclined plane, it is initially in the state of the rest. Whenever the downward pulling force value will be equal to the frictional force, then the body will be ready to slide. So that in this case, limiting frictional force value is nothing but mg sin theta. When the object will be ready to slide, whenever the applied force value will be equal to limiting friction, then the body will be ready to slide. So in the problem clearly they mentioned the body will be just begins to slide down. That means the pulling force, downward pulling force value equal to limiting friction. So here they are asking the limiting frictional force value. Mass of the block is equal to what? 2, and the G value we will take 9.8, and the angle of inclination is equal to 45, sin 45. So that this value is equal to 19.6 sin 45 degrees. 19.6 sin 45 degrees. That is about problem number 56. Next, problem number 57, important one. The lengths of the smooth and rough inclined plane of inclination 45 will be remain same. So here two different planes are considered. One is the smooth inclined plane. Another one is a what? Rough inclined plane. S is indicating the smooth inclined plane, R is indicating the rough inclined plane. And for both the planes, they will be having the same length and the same angle of inclination. Theta value is equal to what? 45. Here also theta value is equal to what? 45. Now, they are asking that the times of sliding of a body on the two surfaces is T1 comma T2 and mu is equal to 0.75. Then find the ratio of T1 is to T2. So, for the rough inclined plane, mu value is equal to 0.75. 0.75. They are asking that what is the ratio of time taken by the body to slide down on the smooth inclined plane as well as the rough inclined plane. So, already we know that for the smooth inclined plane, the time taken by the body to reach the bottom of the inclined plane is equal to T1 is equal to under root of 2L by G sin theta. For the rough inclined plane, the formula becomes to what? 2L by G into sin theta by, so G into sin theta minus mu k cos theta. So these are the formulas of T1 comma T2 respectively. They are asking their ratio. T1 by T2 is equal to 2L by G will be remain same, so that this term will be coming to the numerator and this term will be in the denominator. So T1 by T2 value is equal to sin theta minus mu k cos theta by sin theta minus mu k cos theta by sin theta. Sin theta. See here, if you substitute the value of theta is equal to 45, theta is equal to what? 45. Or one more simplification we will did. Sin theta by sin theta 1 minus mu k into cos theta by sin theta, that is what? Cot theta. Okay na? So here cot 45 also 1, so that this value is equal to under root of 1 minus mu k value is equal to what? 0.75. 1 minus 0.75, 0.25. So under root 0.25 is equal to what? So 0.5. That value is equal to what? See here. This value is equal to what? 0.25. That is equal to within the root of 1 by 4. That value is equal to 1 by 2. The ratio becomes to what? 1:2. Like this we have to simplify the numerical number 57. 57. Next one. Problem number 58. A block slide down a rough inclined plane of a slope angle theta with a constant velocity. So we will consider the first case. The body will be sliding downwards with a constant velocity, along the rough inclined plane. If a velocity value is equal to constant, acceleration is equal to dv by dt, that value is equal to 0. Once again, if the velocity value is equal to constant, the rate of change of velocity is equal to acceleration, that value is equal to 0. Which type of inclined plane they assumed here? Rough inclined plane. For the rough inclined plane, you know the general formula for the acceleration. A is equal to G into sin theta minus mu k cos theta, whose value is equal to 0. Once again, what they mentioned? Velocity of the sliding down body is equal to what? Constant. If a velocity value is equal to constant, acceleration value is equal to 0. But I know the acceleration general formula. A is equal to G into sin theta minus mu k cos theta. I am equating this value is equal to what? 0. If you equating that value is equal to 0, sin theta value is equal to, you will get mu k cos theta. So from the first statement, what we will get here? Sin theta value is equal to mu k into cos theta. Now, it is then projected up with the same plane. And with the initial velocity of v, the distance travelled by the block before it is coming to the state of the rest. Now, the same object they considered, and same inclined plane is also considered. Same object is considered and same inclined plane. Same inclined plane means the frictional force which is acting on the block does not be changes. So that whenever the block will be projected upwards, so already we derived the formula for distance travelled by the block before coming to the state of the rest. What is that formula? S is equal to V square by, velocity of projection is equal to V square by 2g into sin theta plus mu k cos theta. So what is the formula we have for the distance travelled by the object on the inclined plane before it is coming to the state of the rest? S is equal to V square by 2g into sin theta plus mu k cos theta. But here mu k cos theta value is equal to what? Sin theta. Mu k cos theta value is equal to what? Sin theta. Therefore S is equal to V square by 2g into sin theta plus sin theta. Sin theta plus sin theta. Sin theta plus sin theta is equal to 2 sin theta. 2 sin theta into 2g, 4g sin theta. Therefore, distance travelled by the block value is equal to V square by 4g sin theta. V square by 4g sin theta. Standard numerical, very, very important one. S is equal to what? V square by 4g sin theta. Next numerical 59. The minimum force required to start pushing a body up a rough inclined plane is F1, while the minimum force is needed to prevent it sliding down is F2. If the inclined plane makes an angle theta with the horizontal such that if a tan theta is equal to 2 mu, then the ratio of F1 and F2 is, once again read the first statement. The minimum force is required to start pushing a body up the rough inclined plane. Problem number 59. So initially the body will be in the state of the rest. Over the given rough inclined plane. Over that body we have to apply which type of force? Pushing force will be applied on the body in upward direction. So that this is the minimum pushing force we are applying on the body in the upward direction. That force value will be taken as F1. F1. So whenever we are applying the pushing force on the body in the downward direction, some forces are acting. So always mg sin theta will be acting in the downward direction and it is a rough inclined plane, so that frictional force is also acting in the downward direction. While you are pushing the block in the upward direction along the downward direction, what are the forces are acting? Mg sin theta will be acting always in the downward direction. Frictional force will be acting in the downward direction. When they mentioned the minimum force, already I told, when they mentioned the minimum force, these two forces to be equal, that is F1 is equal to mg sin theta plus F is equal to, directly I am writing, F is equal to mu mg cos theta. So whenever they are mentioning that the minimum pushing force means the minimum pushing force value equal to sum of the two downward forces, that value is equal to what? F1 is equal to, directly I am writing, mg sin theta plus F, but frictional force value is equal to, already we know that F is equal to mu mg cos theta. Therefore F1 value is equal to what? Mg sin theta plus mu mg cos theta. In the second case, the minimum force is needed to prevent it from the sliding down is, see here, that means actually the body will be sliding downwards. Whenever the body will be sliding downwards, mg sin theta will be acting in the downward direction and a frictional force will be acting in the upward direction. What they are saying, to prevent its motion in the downward direction. So in the upward direction, we have to apply some minimum force. That minimum force applied in the upward direction will be taken as F2. In equilibrium condition, again we will write F2 plus the frictional force is equal to mg sin theta. F2 plus the frictional force value is equal to what? Mg sin theta. From this, F2 is equal to mg sin theta minus F. Therefore, mg sin theta minus mu k mg cos theta. Now their ratio values they are asking. So that F1 by F2 is equal to F1 by F2. So here if you take mg will be the common factor, sin theta plus mu k cos theta by, in the second also if you take the mg will be the common, sin theta minus mu k cos theta. mg will be getting cancelled. See what left here? Sin theta plus mu k cos theta by sin theta minus mu k cos theta. So in the numerator and denominator, I am dividing with the cos theta, so that this term by cos theta plus this term by cos theta. So here sin theta by cos theta, tan theta plus cos theta will be getting cancelled, plus mu by sin theta by cos theta, tan theta minus mu. Now what they given? Tan theta is equal to 2 mu they told. Tan theta value is equal to what? 2 mu. If tan theta is equal to 2 mu plus mu by 2 mu minus mu, 3 mu by mu. So this ratio value is equal to 3:1. That ratio value is equal to what? 3:1. So simple basics we have to understand the problem what they are asking. Next, problem number 61. Problem number 61. A body is released from the top of a smooth inclined plane of inclination theta. It reaches the bottom with a velocity v. So here problem number 61. Which plane they considered? Smooth inclined plane. From the top of the inclined plane, an object will be released. As a result, while it was reaching the bottom of the inclined plane, it will be gaining some velocity. That formula we derived. What is the velocity gained by the object on reaching the bottom of the inclined plane? V is equal to under root of 2gl sin theta. V is equal to, what is the standard formula? Under root of 2gl sin theta. Now, if the angle of inclination is doubled for the same length of the plane, in the initial case angle of inclination is equal to what? Theta. In the second case theta becomes to 2 theta, length will be remain same. What will be the velocity of the body on reaching the ground will be? So we are assuming that the final velocity value is equal to v dash. So here 2 will be constant, g will be constant, length is also constant, but the angle will be doubled. So in the place of sin theta, what we have to write? Sin 2 theta. In the place of the sin theta, what value we have to write? Sin 2 theta. Now equation 2 by 1, v dash by v is equal to under root of this 2gl will be getting cancelled, sin 2 theta by sin theta. What is the sin 2 theta formula? 2 sin theta cos theta. Therefore under root of 2 sin theta cos theta by sin theta. Sin theta will be getting cancelled. V dash by v is equal to 2 cos theta whole power 1 by 2. V dash is equal to v into 2 cos theta whole power 1 by 2. V dash is equal to what? V into 2 cos theta whole power 1 by 2. Like this we have to solve. Simple formula we have to remember. V is equal to under root of 2gl sin theta. Problem 62. Already we solved the problem number 59. Same concept. 63 will be the direct formula that is in the material. 64. Very, very important one. 64. The upper half of the inclined plane of inclination theta is perfectly smooth, while the lower half is rough. So here, up to now what we discuss? Either we discuss about the smooth inclined plane or rough inclined plane. But in the given inclined plane, the first half of the portion will be the smooth inclined plane. This is the smoother portion and this is a what? Rough one. So, first half of the portion will be smooth one and the next half will be the rough inclined plane. Now, a block starting from the rest at the top of the plane will be again coming to the rest at the bottom. So, initially from the top of the inclined plane, a block was released. A block was released means what? It's a kinetic energy value. Initial kinetic energy value is equal to 0. Since the initial velocity value is equal to 0, initial kinetic energy value is equal to 0. And again they are saying that while it reaches the bottom of the inclined plane, its final velocity again equal to 0. That point we have to understood. Initial velocity is equal to 0, final velocity is equal to 0. If initial velocity is equal to 0, initial kinetic energy is equal to 0. If the final velocity equal to 0, as a result we will also said its final kinetic energy is equal to 0. Final kinetic energy is equal to what? 0. Now, what they are asking? The coefficient of friction between the block and the lower half of the plane is, since the only lower half will be the rough inclined plane, so that whenever the block will be on the rough inclined plane, what is the coefficient of friction value between the block and the rough inclined plane? Mu value they are asking. So here, to solve this numerical, we are using the work energy theorem. Which theorem? Work energy theorem. According to the work energy theorem, work done by all the forces is equal to change in kinetic energy. Work done by all the forces is equal to what? Change in kinetic energy. Here, the thing what we have to understood means, from where to where gravitational force will be present, from where to where frictional force will be present. So here, this point I am taking as the point A and this point will be taking as the point B, and this is the what? C. First we will discuss about the rough inclined surface. The rough inclined surface will be existed from where to where? B to C. Is it right? The rough inclined plane will be existing from where to where? B to C. That means in that B to C only frictional force will be existed. So that in this region only frictional force will be existed. Frictional force will be existing from where to where? B to C. But the gravitational force will be existing along the inclined plane. That point we have to understood. Gravitational force will be existing along the total length of the inclined plane. Now, so according to the work energy theorem, we are writing that work done by the gravitational force plus work done by the frictional force is equal to change in kinetic energy. Work done by the gravitational force plus work done by the frictional force is equal to what? Change in kinetic energy. Gravitational force is always acting in the downward direction and the displacement of the block is also in the downward direction. So that always the work done by the gravitational force will be the positive. So that work done by the gravitational force is equal to gravitational force of magnitude is equal to mg sin theta, and up to what length it was present? It was present along the entire length of the inclined plane. And work done by the frictional force is equal to frictional force of magnitude is equal to mu mg cos theta. Frictional force of magnitude is equal to what? Mu mg cos theta, and its displacement value is equal to L by 2 and the right side term is equal to 0. Here, work done is equal to, we are writing the force into displacement. Work done is equal to what? Force into displacement. Now, we will write mg sin theta into L is equal to mu mg cos theta into L by 2. Mu mg cos theta into L by 2. mg cancel, L getting cancel. See here, 2 will be cross multiplied, 2 into, here sin theta will be there, here cos theta will be there. Sin theta by cos theta is equal to mu. Therefore, mu is equal to 2 tan theta. Very important numerical, standard one. So, the answer is what? First option, mu is equal to 2 tan theta. Next, another important problem, 65. See here. A 30 kg box has to move up an inclined plane of slope 30 degrees to the horizontal with uniform velocity of 5 meter per second. So, here we consider one inclined plane. Over the inclined plane, an object of mass m will be placed. Over the inclined plane, what was kept here? A mass of how much? 30 kg block will be placed. Mass of the object is equal to 30 kg. Here, what is the motion of the block and how it was existed means, this block is moving in the upward direction with a constant speed or with a constant velocity. How it was moving along the inclined plane? It is moving up the plane with a constant velocity. This type of numerical we solved. If velocity v is equal to constant, what we know? Acceleration value is equal to 0. Acceleration value is equal to what? 0. Now, if the frictional force retarding the motion is 150 Newton, frictional force acting on the block, since the motion will be in the upward direction, frictional force acting on the block is equal to what? 150 Newton, which is acting in the downward direction. The horizontal force that is required to move the box up is. So here, over the given box, which type of force here we applied? Horizontal force we applied. Which type of force we applied here? Horizontal force. They are asking that how much horizontal force is applied on the block? How much horizontal force is applied on the block to move it up the plane with the constant velocity? That is the problem they ask. So here, if a force F will be acting in this direction, so the component of the force acting along the inclined plane is equal to, what? F cos theta, and another force is also acting in the downward direction. That the force value is equal to what? Mg sin theta. Since the object is traveling with the constant velocity is equal to constant, acceleration is equal to 0. Therefore, net force acting on the object is equal to 0. Net force acting on the object is equal to what? 0. If net force is equal to 0, upward pulling force is equal to downward force. That is mg sin theta plus frictional force. What is the angle of inclination they given? The angle of inclination is equal to 30 given, so that F into cos 30 is equal to mass of the block is equal to 30 kg into G value 10 they mentioned into sin 30 1 by 2 plus F value directly they given by 150. So if you simplify, so the right side value is equal to 300. Right side value is equal to what? 300. F into cos 30 is equal to root 3 by 2. F is equal to 300 into 2 by root 3 Newton. So what is the horizontal force is required? F is equal to 300 into 2 by root 3 Newton. So simple logic we have to apply. We have to understand the problem here. In which direction the force is applying and in which direction how the object was moving, that a point we have to catch. Okay. So very important. Next problem, 67. A block of weight 200 Newton is pulled along the rough horizontal surface at a constant speed by a force of 100 Newton acting at an angle of 30 degrees above the horizontal. So it is also basic concept. See here. Here a block of weight weight mg is equal to 200 Newton, which is acting in the downward direction. It is pulled along a horizontal surface at a constant speed by a force of 100 Newton acting at an angle of 30 with the horizontal. So, this object will be pulling with a force of 100 Newton, which is making an angle 30 degrees with respect to the horizontal. Like that we are pulling the object. Already we discussed pulling and pushing concept. That a block is pulling with a force of 100 Newton, which is making an angle of theta is equal to what? 30 degrees. As a result, the object will be moving with the constant velocity. Just now only we told, whenever the object is traveling with the constant velocity, acceleration of the object is equal to 0. Acceleration of the object is equal to 0 means what? Net force acting on the object is equal to 0. When the object is traveling with the constant speed, acceleration is equal to 0 as well as F net is equal to what? 0. Now, what value they are asking? They are asking that the coefficient of kinetic friction between the block and the surface. So, since the motion of the block will be in this direction, so the component of the force which is acting along the horizontal direction is equal to what? F cos theta. If it is a F, it is a theta. F cos theta force will be acting in this direction and a frictional force will be acting in the backward direction. Since F net is equal to 0, we will write horizontal pulling force is equal to frictional force. Horizontal pulling force is equal to what? Frictional force. Here, F value they mentioned by 100 Newton and theta value is equal to what? 30 cos 30. Frictional force is equal to mu k into normal reaction. Here, 100 cos 30 is equal to root 3 by 2. Next, mu k value we have to calculate and n is nothing but weight of the given block. So, here, this is a 2 times mu k is equal to root 3 by 4. Mu k is equal to what? Root 3 by 4. If you simplify, you will get that value is equal to 0.43. So, it is based upon the pulling of a given block. Next one is a pushing concept, problem number 68. So, this is based upon what? A pushing of a given object. See, this is the object. A block of weight 10 kg is a rest on the horizontal table. Mass of this given block is equal to what? 10 kg. Mass of this given block is equal to what? 10 kg. And the coefficient of friction value will be given by 0.5. Coefficient of friction value is equal to what? 0.5. Now, they told that if a force is acting in the downward direction at 60 degrees with the horizontal. See here, its weight value is equal to what? 100 Newton. Weight is acting in the vertically downward direction and a force is acting on the block. The force is acting on the block which is making 60 degrees with respect to the horizontal. Like that a downward force is acting on the block which is making an angle of 60 degrees with respect to the normal. Then how large can it without causing the block to move? So, we have to calculate the applied downward force value. If F is making an angle of 60 with the horizontal component of the force is equal to F cos theta and vertical component is equal to what? F sin theta and frictional force will be acting in the towards left side direction. So, here what is the normal reaction value? Normal reaction value is equal to mg plus F sin theta. And frictional force value will be balanced by the F cos theta. So, frictional force will be balanced by F cos theta. So, frictional force value general formula is what? F is equal to mu into normal reaction. Therefore, F cos theta is equal to mu into normal reaction value is equal to what? Mg plus F sin theta. So, here F will be the common cos theta minus mu into sin theta is equal to mu mg. F is equal to mu mg by F is equal to mu mg by cos theta minus mu sin theta. Substitute all the values in this given equation, you will get the required pulling force, required pushing force. That value is equal to 746 Newton. If you substitute all the values, you will get F value is equal to what? 746 Newton. Next, 69th direct concept, it is minimum pulling force required mg sin phi by cos of theta minus phi. That derivation we derived, and 70 also same concept. Next, uniform circular motion. 71, that is also we derived. See here, the maximum speed of the car on the curved path of radius r and the coefficient of the friction is mu k, then v is equal to direct formula, v is equal to what? Under root of mu k gr. Next one, problem number 76, important one, problem number 76. See here, a uniform chain of mass capital M, and a length L is rotated in a horizontal circle, about its one of the end, with a constant angular velocity omega. The tension at its axis is, see here, so this is the axis of rotation. We are assuming that with respect to this axis of rotation, a chain is rotating in the horizontal circular path. The chain will be rotating in the horizontal circular path. So we have to calculate the tension produced within the chain. For that, actually what they mentioned that the total length of the chain is equal to L, total mass of the chain is equal to what? Capital M. So here I consider a small portion of the mass whose mass will be taken as a dm. Dm. Generally we know that if any one of the object will be revolving in the circular path, tension developed is equal to mr omega square. So this is the tension developed within the string whenever the object will be revolving in the horizontal circular path. So here I consider the small portion, that a small portion of mass value is equal to, since it is a uniform chain, mass per unit length value will be constant. So I am assuming that the length of the small portion is equal to dx, and it is taken at a distance of x. So that dm is equal to m by l into dx. dm is equal to what? m by l into dx. Like that, we specified a small portion of the mass whose mass is equal to what? m by l into dx. Now we have to imagine that this mass of dm with the radius of x, it is revolving in the horizontal circular path. Whenever it is revolving in the horizontal circular path, tension was developed. That tension value we are going to calculate now. So here the tension developed will be taken as the dt is equal to, according to this basic formula, mass is equal to dm, and radius of the circular path is equal to x, and omega value will be constant, that is omega square. So small amount of the tension that was developed within the string is equal to what? dt is equal to dm into x into omega square. Now I want to calculate the total tension value. For that we are going through the integration. So total tension T is equal to integral limits from 0 to L. Why? The total length of the chain will be extended from 0 to capital L, so that the limits will be taken from 0 to L, and we have to substitute this value dm into x into omega square. So total tension capital T, integral 0 to L dm into x into omega square. Substitute the value of dm in this given equation. Integral 0 to capital L, dm value is equal to m by l into dx. Again this term will be there, x into omega square. Here total mass of the chain is equal to constant, Total length of the chain is equal to constant, omega is also constant. So that m by L into omega square integral 0 to L x into dx. So this is the final equation we got here. So integration formula, integral of x power n into dx is equal to x power n plus 1 by n plus 1. Integral of x power n into dx is equal to what? X power n plus 1 by n plus 1. So x power, how much value will be there here? 1 will be there. So that this value becomes to m by L into omega square. That value becomes to x square by 2 by using this formula, standard integration formula. Integral x power n dx is equal to what? X power n plus 1 by n plus 1. So here first we have to substitute the upper limit, then lower limit. So m by L into omega square, upper limit value L square by 2 minus 0. M by L into omega square, this value is equal to L square by 2. LL getting cancelled, therefore required value is equal to 1 by 2 ml omega square. 1 by 2 ml omega square. Again one more important problem. So option number 4 is the correct option. Next numerical 78. 78. A particle is moving along the circular path with a speed is v, and it is increased by g in 1 second. G in 1 second. So what they mentioned, a particle is traveling with the speed v. A particle is traveling with a speed v, and its speed value will be increases at what rate? So they mentioned that the rate of change of the speed will be given by g in 1 second. G in 1 second, which is giving the tangential acceleration. Tangential acceleration. If any one of the particle is revolving in the non-uniform circular motion, the object will be having two types of accelerations. One of the acceleration will be acting towards the center. That acceleration will be calling as a word centripetal acceleration. Another acceleration will be acting along the tangent. That acceleration will be calling as a word tangential acceleration. Whenever the object is traveling in which motion? Non-uniform circular motion. It is having two types of accelerations. One is a centripetal, another one is a what? Tangential accelerations. So they are asking that what is the net acceleration of the particle? So here, if the speed is equal to v, we will write the centripetal acceleration is equal to v square by r. According to the given data, tangential acceleration value is equal to small g. Tangential acceleration value is equal to what? Small g. Now, always these two are acting right angles to each other. The net acceleration will be given by net acceleration is equal to under root of ac square plus at square. AC square plus AT square. That value is equal to AC is equal to V square by R. So that is squaring on both sides means V power 4 by R square plus G square. So according to the given options, it will be given by V power 4 by R square plus G square whole power 1 by 2. So this is the net acceleration value. Net acceleration value. Next one. Problem number 79, very important numerical 79. Here they given a hemispherical ball is given. A hemispherical ball is given whose radius is equal to capital R. Whose radius is equal to what? Capital R. A small particle is released from the point P. As it reaches the point Q, its kinetic energy becomes to what? Capital K. The force exerted by it on the hemisphere at Q is, see here. Here they consider two different points. This point is a capital Q. This point is a capital P. Radius is equal to what? Capital R. So initially from the point P, a body was released. A body was released. Whenever the body was released, at the point P, initial velocity is equal to 0, but it is having the maximum potential energy. So, at the point P, initial velocity is equal to 0. Therefore, kinetic energy value is equal to what? 0. And with respect to the point Q, it is at a height of h is equal to capital R. With respect to the point Q, P will be at what height? H is equal to capital R. So, according to the potential energy definition value, potential energy is equal to mgh, that value is equal to mg into R. But at any one of the point, total energy will be conserved. Its total initial energy will be what? Capital K. Its energy is equal to what? Capital K. Therefore, the total kinetic energy value is equal to potential energy K is equal to mgr, so that mg value is equal to K by R. Mg value is equal to what? K by R. Now, whenever the ball will be reaching the point Q, kinetic energy value becomes to be maximum. So that at the point Q, kinetic energy value will be represented by capital K. That value is equal to what? Half mv square. From this, 2k by m is equal to v square. Second equation what I wrote, 2k by m is equal to what? V square. Now, what value they are asking? Whenever the object will be reaches the point Q, what is the force exerted by it on the hemispherical ball, or the force exerted by the hemispherical ball on the given ball? If you draw the free body diagram, at the point Q, weight mg will be acting in the downward direction. Normal reaction will be acting in the upward direction. If v is the velocity of the object, so that the net force acting on the ball at the point Q is equal to n minus mg. And why n minus mg? Always the centripetal force is acting towards the center of the circular path. Always the centripetal force is what? Acting towards the center of the circular path, so that normal reaction will be greater than the weight. And F net value is equal to what? mv square by capital R. Already we know that centripetal acceleration is equal to v square by r. Centripetal force is equal to what? mv square by capital R. Already we know that radius value is equal to capital R. mv square by capital R is equal to n minus mg. Now we are going to calculate the n value. N is equal to mg plus mv square by r. But what is the value of mg? Mg value is equal to k by r. Mg value is equal to what? K by r. Next, here m by r into what is the v square value from the equation 2? V square value is equal to 2k by m. 2k by m. Mm getting cancelled. So this is the k by r, this is the 2k by r. So the required answer is n is equal to 3k by r. Required answer is equal to what? 3k by r. So keep in mind, whenever the particle is traveling in the circular path over that object, centripetal force is always acting towards the center of the circular path. Centripetal force is always acting towards the center of the circular path. From that basic point only we solved this one. So that value is equal to what? N is equal to 3k by r. Numerical. Problem number 86. It is related to the banking of the roads. A vehicle is moving with a velocity v on a curved road of width b and radius of curvature capital R. For counteracting the centrifugal force on the vehicle, the difference in the elevation is required between the outer and inner edges of the roads is. So already we discussed in the concept of the banking. To avoid the skidding of the vehicles on a highways, the outer edge will be a little bit riser with respect to the inner edge. So in the case of the banking, the angle of the banking will be given by the equation tan theta is equal to, you wrote the formula, v square by gr in terms of the speed of the vehicle and radius of the circular path, radius of the circular road. Angle of banking will be given by the relation tan theta is equal to what? V square by gr. So here I am assuming that the outer edge will be raised a little bit by a height of delta h with respect to the inner edge. So for the smaller angles, I will consider the sin theta value. Sin theta value opposite side by hypotenuse, that value is equal to delta h by r. Delta h by r. If theta will be small, sin theta is equal to what? Tan theta. Therefore, in the place of the tan theta, we will substitute this value. Delta h by r is equal to v square by gr. Sin theta is equal to what? Delta h by b. So that delta h by b is equal to what? V square by gr. So what we need? Delta h value v square b by g into r. So this is the required answer for the numerical number 86. First option is the correct. Next, problem number 87. The centripetal force is required for 1000 kc car traveling at 36 km per hour to take a turn by 90 degrees traveling along the arc of length of 628 meters. 628 meter. So see here, problem number 87. What the data they given? Mass of the car is equal to, given by, mass of the car is equal to 1000 kg and speed of the car is equal to, they given by 36 km per hour. 36 km per hour. So convert into the meter per second. This value is equal to 10 meter per second. Whenever kilometer per hour is given, to convert into the meter per second, with which value we have to multiply? 5 by 18. 5 by 18. If you multiply the kilometer per hour values with the 5 by 18, the required value will be in meter per second. Now, which type of path they considered? They consider the arc whose angle is equal to 90 degrees. See, this is the circular arc they consider. A to B is the circular arc. Along this arc, the vehicle will be traveling, which is making an angle of theta is equal to what? 90 degrees. Now we have to calculate the centripetal force. Centripetal force is always acting towards the center of the circular path. To calculate the centripetal force, what is the centripetal force formula? F is equal to mv square by r. M is there, V is there, but R value is not there. So for the arc length, if L is the length of the arc, we know the general formula, arc length L is equal to R into theta. What is the L value here? L is equal to what? 628 meters. 628 meters. R value we need. Theta value is equal to pi by 2. Theta value is equal to what? Pi by 2. So R is equal to 2 into 628 by pi. 2 into 628 by pi. So if you substitute all these values in the equation of Fc is equal to mv square by r, you will get the answer of, so that is centripetal force is equal to what? 500 Newton. Centripetal force value is equal to what? 500 Newton. Like that we have to calculate numerical number 87. Next one. See here, problem number 18.9. A particle of mass m is suspended from the ceiling through a string of length L. The particle is revolving in the horizontal circle. The speed of the particle is. See, already we discussed this type of concept. So a string is revolving in the horizontal circle. Whose length is equal to L and radius is equal to what? R. So this object will be revolving in the horizontal circle. What value they are asking? The speed of the revolving particle is. So if you resolve the weight mg will be acting in the downward direction. So this is the angle of inclination theta. So this component is equal to what? T cos theta, and the tension which is acting towards the center is equal to what? T sin theta. So from this we will write T sin theta value is equal to mv square by r. mv square by r. So what is the r here? Radius of the circular path. Radius of the circular path. So here, what is the sin theta value? Sin theta value. This value becomes to what? Under root of L square minus R square. Adjacent side value is equal to what? Under root of L square minus R square. Substitute the all values. So see here, T cos theta value is equal to what? Mg. T cos theta is equal to what? Mg. From this T is equal to mg by cos theta. T is equal to what? Mg by cos theta. In the place of T, mg by cos theta into sin theta m by r into v square. So see here, will be getting cancelled. G into sin theta by cos theta is equal to what? Tan theta. Tan theta is equal to, from this given diagram, opposite side by adjacent side. So tan theta value r by L square minus r square whole power 1 by 2 is equal to v square by r. From this we will get v square is equal to r square into g by L square minus r square whole power 1 by 2. If you simplify the v value is equal to r square square root r into g power 1 by 2 by L square minus r square whole power 1 by 4. Whole power 1 by 4. Simple calculation will be there. So like this we solve the problem number 89. So these are the numericals of friction concept. So friction concept is completed. Newton's laws of motion and friction is completed. In the next class we are going to discuss about the conceptual part of the work, energy and power.